So as I will start the presentation, can you please remove your webcams, and then I'll start presenting, and you can connect again with the webcam when we start the discussion. Thank you.
Okay.
So hi everyone, we're just gonna wait a few minutes until everyone connects. In the meantime, you can use the little question box to, well, say where you're from, and then we'll get started in just 1 or 2 minutes. Nice. How many people do we have? Okay. Well, I'm going to start, and then people will tag along. So, well, thank you for joining us this morning. I'm Melvin Pells. I'm the Corporate Innovation Manager for Choose Paris region. I'm based in the US in San Francisco. And well, we're going to talk about sustainable construction today. Here is our agenda. So I'll first make a small introduction about Choose Paris region, and then we'll jump into the topic with market analysis and some interesting figures about sustainable construction. And then we'll have our fireside chat with Guillaume Bazouin from Leonard by Vinci, and Kaustubh Pandya from Brick and Mortar Ventures. And finally, we will have some innovative companies that we selected who will be presenting their solution. So Choose Paris region is a business and innovation catalyst. We partner with a Fortune 500 corporation to support international companies willing to expand in the Paris region. Thanks to our presence, well, in vibrant ecosystems, you can see here, San Francisco, New York, Beijing, Shanghai, Shenzhen, and well, of course, Paris. We are in touch with over 4,000 companies, international companies every year. And thanks to this unique relationship with large corporations on the one hand, and innovative, fast-growing companies on the other hand, we foster business and technology partnerships between large corporations and startups. We cover an array of technologies. So let me yes, to the next slide. It was a bit fast. Yeah, we cover an array of technologies, including artificial intelligence, robotics, big data, IoT, AR, VR, and a bunch of different industries also. So we deal with the mobility industry, smart cities, retail, and well, today we're going to talk about sustainable construction. Here we have some key figures to tell you a bit more about why we decided to pick this topic. So, well, the first number, 8% of CO2 emissions from human activities come from the cement industry. So this is a huge number. For example, some people often talk about, the air travel industry, but the air travel industry only represents 2.5% of CO2 emissions from human activities. So this is really huge, and this is why it has to be reformed, and some innovative solutions are needed. Then the other interesting number is 1.1 billion tons of waste. This is what is expected to be produced by the construction industry by 2025, which is basically tomorrow. And this is half of the solid waste generated worldwide. So when we talk about solid waste, we talk about wood, plastic, ceramic, bunch of different things. So in the industry, it's called ABC, asphalt, brick, and cement debris. And an important precision is that out of this waste, only 10% is produced by new construction, and 90% is produced by demolition of buildings. So this shows the need to tackle demolition, look at the full life cycle of buildings, and not only develop new materials to build new things, but also think about how to reuse it after the life of the building. Then we have 68%, which is the number of people who will live in urban areas by 2050, and that resonates with the graph on the right that shows like some pretty interesting perspectives for the construction markets, in particular the US and China, which are the two biggest construction markets in the world. And well, to address these needs, we identify three big trends. So the prefabricated and modular construction, which is very interesting because it allows to produce buildings faster, to reduce the cost, and also to reduce the amount of waste. So I was mentioning the amount of waste produced by construction. Thanks to prefabrication, the industry is able to reduce waste by 52%. This is really significant when you look at the numbers. Of course, there's a lot of other efficiencies thanks to this. And then I want to be mindful about the time, so just a few words about information technology and advanced materials. So advanced materials, of course, it's everything recycle, everything that uses new resources, and information technology is BIM. So thanks to this, we just improve efficiencies, and we're able to have a more sustainable construction. Now, I want to show you a market map that we established based on the companies we identified for this event. So I'll share my contact information at the end of the webinar. Feel free to reach out if you're interested in getting this market map or chatting about it. So in the modular and prefabrication category, we have companies that are able to produce, to pre-produce some elements. So Catera, I think, doesn't need any introduction now. They produce different parts for the construction industry. We have companies that produce entire homes. This is the case of Blockable, for example. And then we have companies that assist these prefabrication companies in handling materials, in handling logistics, etc. And this is the case of Manufacton. Then for the 3D printing category, we have companies that are going to 3D print buildings on site. This is the case of Genesis Dimension, for example. This company uses mechatronics to build on-site entire buildings. And then we have other companies that use off-site techniques. This is the case of Branch, but we will hear a bit later about Branch technology. For the information management, I mentioned it a little bit earlier with the key figures, but the idea here is basically to reduce inefficiencies, to reduce errors, and in the end have a more efficient way to build. Then for the low carbon concrete, the idea is to have a type of concrete that integrates CO2, so it's going to lower the impact in terms of CO2 emissions. Companies like Carbon Cure, for example, integrates CO2 directly in the fabrication process, in the production process of concrete. And some other companies like Concrete Canvas are going to reduce the need for concrete by some new processes. So I really, you should really look at this company, Concrete Canvas. It's pretty interesting. And then for the advanced materials and carbon upcycling, well, the idea is to use some already existing materials and turn them into something better, or use something that's very abundant to turn it into something that can be used for the construction industry. This is the case, for example, of Mycotech. They use a mix of mycelium, so mushrooms, and bamboo to build bricks for the construction industry. And another example is Blue Planet. They use CO2 to make stone, basically, that can be used as aggregates for the construction industry. So that's about it for this market map. I would like now to move on to the discussion with our two experts. So I'll invite you guys to join me with your webcams.
Hi.
Hey. Hi, guys.
Hello.
So what about you, a small introduction about yourself and say a few words?
Sure, you want to start?
Okay. Go ahead. Go ahead, Guillaume.
Okay, I'll start. Well, first of all, thanks very much for having me tonight or this morning, wherever you are. My name is Guillaume Bazouin. I'm the head of open innovation and startup programs at Leonard. We have a couple programs that we operate that I might talk about later, but to keep it short, Leonard is the innovation and foresight lab for Vinci as a group. We have really activities that span from looking 15 years into the future for what's going to happen with autonomous connected and electric vehicles, and then going all the way to having a startup program where we identify extremely early stage companies and have a YC type of approach in financing them. And that's a whole range of activities. For those of us who do not know necessarily Vinci, Vinci is one of the world leaders in construction and infrastructures, both in terms of the contracting part of it, the GC part of it, building it, and the operations part of it. We operate concessions around the world in terms of airports, railways, and highways. Some of them you might not know and might be using every day. That's the case for a highway in Southern California, for instance. It's the case for a large construction company that's in on the eastern seaboard of the United States, in North Carolina, that builds roads. So anyway, I'll stop it there. And again, thanks for having me.
Great. Thank you. So yeah, Vinci is everywhere, for sure. A short introduction of myself. So Kaustubh Pandya, I do go by KP, if that's a hard name to pronounce, I understand. My background is in civil engineering, and I work at Brick and Mortar Ventures. I'm a principal here. For those of you who don't know us, we are investors, the venture capital firm. We are investors in technology that helps us design, build, and operate and maintain the world around us. We are agnostic to business model, agnostic to a region. We invest globally, and we are seed and early stage investors. We are backed by players in the construction value chain, so material players, equipment rental players, tool players, contractors. Most of the team comes from the construction background because we believe that is what is needed to understand the industry and figure out what problems are the motivated to solve that helps us make better bets. So we can get into that plenty, and particularly on how we look at sustainability and sustainable construction as a topic.
Sure, thank you guys. And so, well, I know you already know each other. Like, can you tell us about like in what way you have been able to work together? Like, how did this happen? And yeah.
I mean, sure. Like from my side, I was working in California for about 10 years. Worked in several startups, including a company called Bone Structure. I was the head of product for, and it's a startup based in Montreal and in California, doing prefab construction. I had the chance to start talking with the brick and mortar folks as part of this company. This going back to Bechtel and Darren Bechtel, which I guess you'll talk about, KP, being quite linked to Stanford, which was a place where I went to do my master's. So it kind of like started there for like the link. And when I moved to France a couple years ago to start working on structuring the startup programs and startup offers we would have at Vinci, naturally I reached out to the people at Brick and Mortar, and really the initial part of it has been we are operating a program called Catalyst from Paris, where we identify about 10 companies every year that we essentially shine a strong light on and help build bridges with the different business units at Vinci. And so we actually do a lot of our deal flow and sourcing and essentially qualification of these different companies via exchanges with different VCs around the world. And the brick and mortar is actually one of them. So we have regular exchanges talking about the different startups that could be deployed within Vinci. And so that's from my side, that's where we're coming from.
Yep. I can add kind of how we view it. So part of the organization's mission for brick and mortar is cultivating centers of influence, and that is strategic organizations that we believe are relevant to moving the industry forward. That's not the LPs, people who give us money, or portfolio companies, the people who we give money, but it is a strategic organization. So a good example of this is us having a free flow of dialogue between here's a problem that they've tried, here's a pilot they might have done, or here's a particular scope that they're looking to solve, and we would be happy to engage and understand what makes that scope unique and how do we solve that problem. A good example of that, recent one is there's a lot of noise in COVID response track and trace solutions. So how do we figure out, based on our collective experience, what solution is best fit for what a region and what problem? So there's a lot of exchange on that front.
Yeah. And well, the topic is sustainable construction. I was curious to hear from you about what importance does sustainability has in your organization? So Kaustubh, is it something that is a priority for you? How do you look at this? What is important when you look at startup for construction?
Mm-hmm.
And you, Guillaume, same thing. Are you willing to help companies working this space? Do you have a priority for this type of companies? And yeah, just share a bit about this.
Yeah, so I'll share operationally and investment-wise. Operationally, we're a 5-people team. We do what we can to be sustainable, but I think that's far and few in between. On the investment side, we consider ourselves investors in solutions to problems that the industry is motivated to solve, not necessarily a technology by itself. So we want to understand, is this a acute problem in the industry? And sustainability and sustainable construction, I would say overall, is a pretty big problem from multiple stakeholders. When we look at sustainable solutions in the space, and especially as they come across our deal flow, I love the map you guys did, and because it not just focuses on the next gen material, which is where a lot of focus goes on when it comes to sustainable construction, but you kind of took the entire scope of it. We look at sustainability as a core driver, but it does have to meet the venture-backed profile that we're looking for. And what does that mean? That means for us to invest, we are looking for velocity. We're looking for a traditional kind of profile that says, okay, can we get a return, a venture profile return on this? What does that mean when it doesn't fit? And we would spend a lot of time to understand, does this company fit, or does this solution fit within that profile? Because a lot of solutions could be a really good private having businesses because they can serve the niche of tech-forward contractors, tech-forward stakeholders, and continue scaling in that business and make an impact in the world. But for it to force into a venture profile, you might be doing a disservice to that company, because now you're putting pressure on it to meet a velocity that we don't think is sustainable. To pun intended, I guess. But in that case, it remains to be seen what is a good fit for that particular company, and that there we would be happy to introduce them to LPs, other strategic organizations, to help them scale. And how do we make them successful? I'll pause there and kind of give you a few examples if helpful.
Yeah, just to build up on that, I read that in emerging countries, for every dollar invested in sustainable construction companies, $4 was like the average return. Like, is it something that you agree with, or like, how do you see this?
That would be, depends on who can capture that dollar. And I think that makes sense. And depends on, so let me peel back a little bit, right? When we look at sustainable construction, we focus a lot on the embodied carbon footprint, and particularly the way what material you're using. But there's a lot of effort and a lot of impact can be done on where the manufacturing and installation of materials going. Because I think, globally speaking, the market for which material is best to use in what vertical and what geography is going to be driven by the market demands, economic factors at play. It's not going to be helpful to direct a particular material, no matter how sustainable it is, because economically it will fall flat. Where does that leave us in terms of returns? I think it depends on the market and depends on the vertical of construction. I will say a vertically integrated player is better positioned to capture such returns than a typically distributed value chain that we see in construction traditionally. And particularly if you're focused on a single vertical in that verticalized construction space. And we have a few actually in our panel, and I think in the audience today that can attest to that.
Great, thank you. And so what about you, Guillaume, and Leonard and Vinci?
So it's I guess in terms of operations, we have a slightly higher impact than the brick and mortars team with 5 people on a daily basis. So there's basically there's really 2 layers to that answers for me. There's the sort of like a corporate answer and what Vinci is currently doing and aiming to do in the future in terms of sustainability at the global level. And then I have something to say as well when it comes to our role, more on the Leonard side as an investor and a promoter of new technologies. So on the Vinci side, and the thing that's interesting is that is a driver for us as the innovation arm, but it's also a driver for the entire industry, right? We actually put as an objective this January that we would reduce our CO2 emissions by 40% by 2030 and reach carbon neutrality by 2050. There's questions about that when you have to look deeper and look at what scopes you're talking about in terms of emission. You'll have to look at how much of it is something that is something that you compensate with carbon credits, part of it that you do yourself. But at the core of it, there's a true understanding that as a major worldwide player, we have a huge responsibility to play for our own operations, but also to pull the industry forward on that level. And I just want to give you a couple of examples of things that we're actually looking at, and that's actually part of a press release. So I'm actually have it open because I don't know everything by heart. But I talked about CO2 emissions reduction. It's also about circular economy. It's about material reuse. It's about reducing general waste. It's about preserving biodiversity when we actually go about building things. It's about, as an operator of a company with 200,000 collaborators, there's all the movements that our people go about doing. So it's about electrifying and reducing the carbon of our fleets. So it's multi-pronged and kind of a gigantic effort. And what I'd say is, we've really identified out of those 40%, maybe half of it or like 2/3 of it that we sort of know how to do already. And we know what to do and we know how it's going to be done and there's a roadmap for it. But then there's a whole nother part to that, and that's kind of like the interesting meaning to that commitment that today we don't necessarily know how to achieve. And that comes through innovation at different levels. The answer is going to come through some things that we do internally, some research on lower carbon concretes, some research on some operational efficiencies that we're going to put together in terms of material reuse. There's a lot of things that we can do in-house, but there's also a lot of things that are coming from outside right now, and we're seeing that with the explosion of construction tech. When it comes to operational efficiencies on the job site. I'm not going to be the one like telling this to KP, who's background at McKinsey, but it's what we can do by deploying best-in-class solutions that might be developed outside is insane in terms of productivity gains, and those productivity gains have a direct impact when it comes to material use, energy use, and time spent on the job site. So that's a huge aspect. You mentioned prefabrication. That's something that everybody's looking at right now. It's also a great avenue to keep exploring. We have, we're looking at it internally, and we're also looking to collaborate with outside players. There's things like that are linked to operational efficiency that I'll just touch on, such as robotics, the deployment of robotics on job site, the ability to do things again with less waste. And so for that whole section, there are activities all around the group happening, sometimes at the business unit level, where you have somebody that's the head of a given piece of work that's going to contract a company like HoloBuilder, for instance, and they're just going to decide this at their level. Then there's things happening at the Vinci construction level, where you would have potential research, R&D collaborations with a company like eConcrete or another one of those people doing like really cool new stuff, new formulations for concretes. And then at yet another level, at the Vinci holding level, at the Leonard level, which we operate mostly from, we have a role that's two-pronged through our two programs. And it's the seed program, which is for extremely early stage companies that we really want to get essentially at the time where it's 2 PhDs coming out of school or of their research institute, and we want to give them the tools to actually go about building a startup, not by making Vinci necessarily the main shareholder in that startup in the long term, just building the ecosystem. And then there's the second program that we call Catalyst, that's about having, like I discussed it earlier in our relationship with brick and mortar, but it's finding the best companies out there to serve our needs. And a huge focus of both of these programs is, and that's what our bosses, our directors and our CEOs are asking us is, you guys need to find the things that are going to help us meet those commitments that we just made, and we don't exactly know how we're going to meet. So it's a bit of a long answer, but there's a lot of things happening in a company this complex.
Yeah. And well, it seems that you really look at outside technologies, like startups and like what's happening out there. So open innovation seems to be like very important in this field. And well, actually, I was reading some numbers about from TechCrunch saying that from 2017 to 2018, the investment in construction companies increased by 320%, something like that. So which is really huge. And I was curious to hear about you, like how mature are these innovative companies? So Guillaume, you were saying that some companies just have 2 PhDs, like this is something that this is a pattern, or you have like more mature companies, like how is the space?
The answer, I mean, KP is going to be better to answer this, but what we're seeing is that varies drastically from location to location, which is generally true for startup ecosystems. But I'll give the proxy with like the number of investors, right? Like number of Contech investors in the United States, KP, you'll tell me, but like upwards of 10. Number of Contech investors in France, today, none. Like there's some people starting to play around with prop tech, which is more like the fintech side, and like, oh, now we can do things with buildings. The people that are hardcore talking about robots on site and things like this, not many. So I'll say, there's a robust ecosystem of startups of many levels of maturity. Some of them that are definitely on their way to become unicorns in the United States. It's somewhat the case in other places, like the Nordics in Europe. It's definitely the case in a place like Israel. There's a strong ecosystem over there. And to talk about France, because we're also doing like Choose Paris region, to me, it's an anomaly at this stage because we have some of the largest AEC companies in the world that are headquartered in Paris in a weird roll of the die. huge numbers of graduates every year coming out of schools, experts in their fields, and yet very few of those actually going into entrepreneurship. So I think there's a tremendous opportunity in France for things to evolve, and it's a long way of me saying it's a budding ecosystem in France. I've been in it for 18 months and I already see it doubling, tripling, quadrupling. I see repeat entrepreneurs looking at Contech, which they didn't do necessarily before in France. And I think it's going to explode everywhere, but very early in France at this stage.
I would echo that. I think if I look at over the last few years, you've seen an increase in investments. A few things that have led to it. One, investors' interest, and we were kind of, I would say, one of the first ones, especially Darren. We internally joke around, it's kind of like going to a party that rest will come, and that has proven to be right. But when you look at the stakeholders, the industry was motivated, the investors are motivated, and particularly a new class of investors that came on over the last few years, couple of years almost, is CVC, the corporate venture capital. A lot of industry players who are putting directly money where they're investing, either through direct innovation, direct investment, or through LPs. And then the third one, in my mind, that allowed this to happen was talent. The first wave of talent that we've seen in the industry were industry experts who learned how to digitize a problem that they had faced in the field and get there. The second wave that we've seen are deep experts in whatever field they are in, and they're increasingly choosing construction as the industry of choice to apply their talents to. So if I'm a robotics expert, if I'm a deep AI ML expert, what are those choices that I have, and why am I picking this one particularly? And that has led to a really interesting influx of talent. We all get benefited from having such talent come into the industry. I mean, bringing back to sustainability and sustainable construction, I think those three stakeholders are still there. The fourth stakeholder in my mind is regulators that can actually supercharge a lot of, I would call it acceleration in the space. I don't think that customers have the same burning needs on a broader scale. There are definitely tech-forward customers, and there will be few that have clear mandates by X amount. Here's my reduction in carbon footprint. We would look at it. What is the broader industry saying, and what are they're not just a tech-forward, because for a venture, return for a venture typical company to be successful, you're looking at much more than the select tech-forward customers.
Yeah. So it's interesting you're talking. Sorry, go ahead.
Yeah, I just wanted to add one thing. Like KP, I know you have more knowledge on this than I do, but an example of that is, Singapore just saying overnight, all right, well, 80% of what we build is going to be prefab from now, and I don't know if it's 80%, and that just happens. And then you have to create an industry around this. I know that some of the startups listening know about this because they were involved with it, but it's a big example of that. We have the same in France and in Europe with energy targets and waste reduction targets. And the industry is starting to realize that these folks making laws they're not joking about it. So it's it's moving fast.
Yeah, and actually, since Kaustubh was talking about regulators, and you seem to be saying that it's important. Are there any obstacles from regulators? For example, when you want to use new materials, new type of concrete, is it an obstacle to have regulations on the type of materials you can use in terms of security, stuff like this? For a corporate like Vinci, is it a problem to be using new materials like this?
So I'm not an expert in this. To a certain extent, we have the ability to try new things as Vinci. For instance, our new headquarters are going to be built at, I don't remember which percentage, but a certain amount of it is going to be built with experimental concrete that's extremely low carbon, things that we've been developing in-house, and we're able to introduce these types of things on our own projects. So that's that's part of the answer. On the regulatory front, I've had the privilege to see both the US version of it and the French version of it. And it's really interesting to see that in France, you have one single regulatory body that's called the CSTB, that actually, you can go through a process that takes a certain amount of time and a certain amount of money, and you will have something that is usable in every single building in France. And one of the things that was very hard, and it's still a struggle for the prefab industry, but it's also something that we're facing with material use in the United States, is the insane diversity and number of regulatory bodies that have to approve any given change to something. And so in making that switch from the United States to Europe and to France, I was, in a sense, like happily surprised to see that sometimes centralization can help for fostering change. So yeah, speaking about the example of France, yeah, there's a bunch of things you need to do, and you're not allowed to, just use new material out of the blue. But there's a clear process to get it through. So I think it works. The future will tell.
Yeah, I would add to that, and this is probably a bit of personal bias coming in here, because I'm coming from a forensic engineering background. I was a structural engineer in the past, so saw a lot of materials fail, and we had to experiment with a whole bunch of materials, all the way from old school masonry to 19-hole wires. And the journey that led me to believe was inherently engineers are very risk averse, and the industry just structured that way where you're not incentivized to take risk, especially on a new material. So the amount of regulation you have to go through, especially for a structural replacement of a member, is definitely hard. I think it doesn't preclude you from making impact where it needs to be. For example, facade panels, or something that is easier to get to under your belt and make progress, which still has considerable amount of volume in the boat world that I can get there. I think the obstacle from a regulation standpoint is not necessarily long term, in that we've seen regulators actually come in and, I would say, accelerate. Maybe not necessarily only on the material side. So here's an example. California allowed ADUs to go faster, right? When we see how are we going to improve our permitting, we submit two plans. One is a permitting plan that is for the site, and one is just a regular prefab plan. That allows you to accelerate how fast I can do prefab modular construction, at least for this vertical in this region. And that is an instance where we've seen regulators take a better approach and accelerate, at least in this case. I think a bigger obstacle in my mind is not necessarily the regulators. I think for startups, the bigger obstacle, at least when I'm putting the venture hat, is the go-to-market cost, and particularly if you're focused on a capital-intensive industry, it may be a next-gen material, which is often the case here. And so the amount of effort you need to get experience under your belt, some amount of material under your belt, and capital intensity required to get there is quite high. And there are approaches that we've seen that allows you to get away from that, and we can chat about. But I think that's a bigger obstacle in my mind.
Great. Thank you very much, guys. So I want to be mindful about the time, so I'd just like to open it up for a couple questions from the audience. So if anyone has questions, please use the chat box, the question box, to send us your questions, and then we can take it from there. Okay, so there's like interesting questions about what is your like very innovative, exciting startup that you've been seeing? Like, is there something you have in mind that really blew your mind when you saw this startup?
You asked me to pick favorite child. Is that what this is? Guillaume, you can go first. I'm happy to chat.
Okay. Well, this one is like more semi-emotional, because it's we just ran our first cohort of our seed program, which is the Y Combinator type program, very early stage, 60,000 euros in safe equity invested in the companies that join our program, and the companies go through a program that we do in partnership with Stanford University that's called Idea to Market. And we get them through a demo day, which we did last week, and had 300 people at any given point show up. So it was like really the first time we did this. And one of the companies that's relevant, I think, for sustainable construction is along the lines of 3D printing, concrete 3D printing, and we've seen a lot of that. These guys are called Soliquid, and it's the example that I mentioned of two founders that are extremely technical. They're architects and engineers, very good on the subject matter, but we're very far from essentially having a value proposition and a business model and a go-to-market strategy that makes it fundable in terms of VC, right? And so I think now these guys are at the stage where essentially they're able to go about raising VC money in France and abroad. And I guess I'll describe what they do. It's when you want to print, do essentially like a concrete 3D printing. Usually you either do layer on layer 3D concrete printing, or you can build or like 3D print in plastic or some other material, some kind of mold, and then you can inject the concrete in there and then break the mold and you have the piece. What these guys did is that they came up with a process where you print your concrete in a bathtub of this dense gel, where essentially you can go about drawing in 3D without having to do layer on layer, and it dries in a matter of a couple hours. So it's really, for me, one of the paths that you can take to actually take parametric design of structures and bring it to construction. So they still have to figure out how to actually go about injecting steel in there so that it's something that's actually structural. But when it comes to the concrete part, they've done something that hadn't been done before in terms of process, and I think is very exciting. So that's one of the ones we're hoping that they're going to be able to go about raising the required amount of capital to go through the things we talked about in terms of regulatory barriers, and in terms of having a hardware prefab that's for construction, where we've had very few exits on the VC side. So it's tough, but I think they're onto some things, and if it's not them, it's going to be something like that ends up being, I think, tomorrow's use of concrete.
Yeah.
I'll keep it very short. And I think if you're looking at impact, near term versus art of the possible in the future and potential for huge impact later, I'm going to focus on this category. And we have a few robotic startups that we invested in, each of them in very different fields that are fundamentally game changers. One of them, and I'll stop here, would be you're talking to Branch Technologies, and you'll see kind of how they went from all the way journey of NASA 3D printing had a challenge to today, and the art of the possible and impact even in the medium term that they are capturing. So I'll pause there.
Yeah. Thank you very much, guys. We have a bunch of questions, and I would love to answer them all, but we need to move on with the startup presentations. Otherwise, we will be way over time. So thank you very much for all your insights. And well, let's keep in touch.
You're welcome.
Thank you.
Thank you very much for having me. And nice to see you, KP.
So now we're gonna do the presentations. I'd like to invite Mariela Alfonso from State of Place to join me.
Hi, it's actually Andy from State of Place.
Oh.
Andy, the CTO.
Hi, Andy.
So, you giving the presentation? Are you going to share the screen, or are you going to do the slides
Yeah,
yourself?
I'll just make you a presenter so you can show your screen and show us your presentation. Yeah, that should be working now.
Great. Can you see it? Okay.
Yeah, perfect.
Great. Okay. Well, I'll go quick because I know we're short for time. So I'm Andy Lukuski. I'm the CTO of State of Place. We're a data-driven predictive analytics firm, and we are kind of more in the urban planning space, but very connected to the development and construction industry. So we are, like I said, predictive analytics team. What we do is we quantify the value of place. We figure out how to make places that people love to live in. We're a combination of urban planners, software developers, and data analysts. So there's a big gap, especially if you're in construction, you know this, between the places that people want to live, work, and play, and the places that have actually been built in the last 70 years and unfortunately are still getting built. And this isn't just a problem in the US and North America, but also in Europe, because there's really a lack of cohesive vision about what kind of places people want and building that quantifies that need. So we need to stop this kind of myopic looking at a building individually and be able to use quantified analytics to build comprehensively and understand the relationship between people and place. And it's not just an aesthetic problem. We have huge problems that come from bad urban design. Trillions of dollars are wasted, millions of deaths around the world, and of course, a huge loss of profit and sustainability opportunity. So if this is a huge problem that we want to solve, why don't we solve it? It's because a lot of the work that gets done right now is well-intentioned, but it's based on intuition and gut instead of data and analytics. So this is where state of place comes in. We actually quantify the value of urban design by analyzing up to 300 different urban design variables in any place. So on a particular street, we'll look at the street configuration, the types of building, the amenities provided, and smaller things like trees and benches to give an overall state of place index from 0 to 100. And this gives you a good view of what's working and not. And we also break it down into different urban design dimensions that are proven to be important to walking. So density, aesthetics, for example, presence of parks, good form, perception of safety, etc. And with this, our customers, which include developers, cities, and other stakeholders in property, can get a quick look at project areas. This is an example of Hong Kong. See how each city block is performing based on urban design and the breakdown of score. And that becomes really useful when you start tying it to forecasting. So based on academic research, we're able to tie that state of place index to different kinds of forecasting, especially fiscal, but also things like public health, sustainability, and traffic safety. So based on the increase in state of place index on a block, we can actually predict higher values of higher return on investment and better public health outcomes. This is an example. You might have a project where spending a certain amount of money gets a state of place score of only 42.8, but spending a little bit more money gets a much higher state of place score, which equates to a much higher return on investment. And we help you do this by actually recommending the type of urban design features to improve. So in this case, it might be driveways and setbacks that really matter, or the way that you treat the undeveloped land. Up to now, we've only used manual data collection, but we've just released visual machine learning based collection. So we've gone from about collecting our data in about 30 minutes per block to being able to collect thousands of blocks in just one day or two. And this leads to all kinds of possibilities in terms of comprehensive neighborhood planning. You can look at the relationship between different streets and also choose sites that have the most opportunity. We're also moving in the direction of a 3D modeling tool. So instead of just form-based, trying different scenarios out, picking values, you're going to be able to design that in a 3D web environment, get instant feedback, and then export it to your design tools. Our goal is to be part of the entire design conception and building process, and that means that you use us as a tool so you can sketch your initial ideas, help plan, get your approvals, do your construction, audit, and do next steps. We're a great team of data geeks and place lovers led by our CEO, Mariela Alfonso, who is the founder and is an international thought leader in urban design and walkability. And please get in touch with me if you have any questions. Thanks.
Thank you very much, Andy. So same thing, if people in the audience want to ask any question, please use the question box. And yeah. So we have a question. Someone is asking, how do you calibrate the state of place index with actual human perception of space and return on investment?
So we're actually based on, we have a social science background, so it's based on about 20 years of researching walkability and seeing the correlation between how urban design variables actually impact behavior. So does the presence of trees lead people to be more likely to walk in a place or less likely? And things like broken windows, of course, lead to less walking. So it's all based on research, and it's all the evidence and research is published online, so you can feel secure about the scoring.
Okay. Someone else is asking about your business model. Can you say a few words about it?
We are a startup, so we've worked with about 40 different cities and organizations everywhere from the Swiss National Railroad to cities like Grand Rapids, Michigan in the US that I showed, and developers. And the model is to sell it as a subscription so that we use visual machine learning to give you access to the data and let you do detailed scenario analysis and use it as a tool through your development process. So we sometimes sell it just as a one-off for a developer who has a particular project, but our preferred model is a subscription that's very affordable, gives you access to the data, and lets you use it however you want.
Mm-hmm. And so how do you see this feel towards digital tools like yours? Like, is it easy to implement, or they're open to it, or like how do you?
Yeah, I mean, we get a lot of excitement from our customers who are new to this kind of tools. They're used to using just basically geospatial tools like ArcGIS, and they want something that's more advanced, where instead of just seeing a bunch of maps with colors, they can actually use the data to make change. And that's the reason we do this, so that we can get better places all over the world.
Great. I love it. You have like short answers. This is perfect for this type of event. And
I have long
one last question. So how long does it take for you to be able to start working in a specific city? Like, how long do you take to collect data, like to analyze it, etc.?
So all of our data is generalized. We use sources like OpenStreetView and OpenStreetMap and Google Street View. So we don't need any specific data from our customers. We can basically start collecting data immediately once the project is defined. So from start to finish, we should be able to get a customer online within a day or two, and in the future, we'll be able to get them online instantly.
Awesome. Well, thank you very much, Andy. And well, we're gonna move on to the next company. Thanks. So the next company is Full Stack Modular. That's pretty famous in this space. So I see that Roger is here. I'll just make you a presenter. Great, we can see the slide now. We cannot hear you yet.
Can you hear me now?
Yeah.
Can you hear me now?
Yes.
And there we go. Okay.
Awesome.
Hello. Okay. So anyway, shall I go or?
Yeah, let's go for it.
Roger Krulak, president and founder of Full Stack Modular. We are a design, manufacture, construct solution for the dense urban environment. Sounds to me like a good marriage of process between state of place. And we built what was at one time the tallest modular building in the world. It's still the tallest in the United States. We are process driven as much as we are product driven. We design, manufacture, and construct buildings, and our focus is primarily multifamily and primarily in the dense urban environment. And you can see a few of the projects here on the right. I don't know what, there we go. Since we were talking about sustainability today, I thought I'd give you a few numbers. 25% lower building cost, 20 to 50% faster in development, extraordinarily safer work conditions, cost and time certainty, far less neighborhood disruption and safety, and then 67% less waste. And of course, our focus now on carbon footprint and all of the other things that drive efficient construction. We are already sustainable by process. So compared to a standard design bid build solution, which will look familiar to anybody who's done any development or worked in it before, versus our design, manufacture, construct solution, we can build, as we said, 20% or so cost savings, 50% faster, as long as the team gets involved in the process. We can establish costs in just a few months because we're obviously moving the majority of construction into a factory environment, which is process driven rather than construction driven. The other thing that we've done as of late is we provide a completely comprehensive solution, meaning that we design, manufacture, and in collaboration with Plaza Construction on the East and West Coast of the United States, can build a complete solution, fully bonded, guaranteed maximum price, all of the things that makes developers comfortable. We have a structural system that in a non-seismic area can build up to 45 stories. We have self-sealing facades, which eliminates the need for scaffolding on the outside of the building. It's a fully integrated solution, as I explained, design, manufacture, construct. It's a built-in sustainability. It's much easier to build sustainably in a factory than it is on site. We, unlike many other prefabricated companies, do almost all of the work in the factory, including the connection pieces that connect it. All of the mechanical, electrical, and structural are distributed as part of the process. There is no other system other than our modular system, and we happen to be made in the United States. The most important thing about what we do is a systemized approach. So our project is based on, obviously, from a multifamily perspective, units, but those units are made out of module types. And the goal in manufacturing is to limit the amount of variability while maximizing the amount of fit to the ultimate product. So you take the minimum amount of module types necessary to meet the program needs and requirements. You take those minimum module locations, you organize them into the program that's required: studios, 1 bedrooms, 2 bedrooms, 3 bedrooms in the case of multifamily, and then those create what we call sub-assemblies, which make up all of those assemblies or all of those unit types. So our process, unlike standard construction divisions, is our assemblies and sub-assemblies. So facades, kitchens, bathrooms, flooring systems, et cetera, are all created in the process of assembling the building. And then, of course, as those unitary pieces are finished in the factory, to the extent possible, then they're brought to the site and stacked up and connected. We are huge believers.
Sorry to interrupt you. Do you think you can wrap up in like 30 seconds or something? So we have time for.
I'm almost done. Almost done. I can wrap up in 20 seconds. We, like most people, are always engaged in combining advanced technologies in our process. For us specifically, metrology, process integration, and then of course analysis of sustainability and appropriate location is where we're focused. And then, as we describe, design, manufacture, and construct.
Awesome. Thank you very much, Roger. So same thing. Do we have questions from the audience? Okay, so someone is asking, how do you transport the finished blocks from the manufacturing site to the construction site?
So they are a wide load. They are volumetric solutions. They can be transported by train, by truck, or by boat. It depends on where they're going. So if they're going to the Caribbean, we're going to put it on a boat. If they're going nearby, we're going to put them on a truck. And if they're going, third of the way across the country, we're going to put them on a train. So.
And then for the last mile, like how do you navigate like dense urban areas, like within a city center, for example? How do you handle the blocks?
To answer the question sort of more specifically, the idea is to pick up and put down the mods as few times as possible. So our goal is always to load something on a truck or a boat, et cetera, and then put it into location the next day or the next hour or the next, et cetera. So we don't want to really take it and then put it in a storage facility and then pick it up again and put it on. So normally it's logistics, and look, we were born in New York, so it's all dense urban environments. It's not a problem. If you think about this, it's 70% less trucks once the foundation is in for our modular solution. So we're just taking the place of something that's 4 times, 5 times as much traffic.
Yeah. And one last question. So in the beginning we were talking about how prefabricated and modular construction is having like a lot of success. So, and you've been in the business for a while now. So have you been an increase in the demand for modular construction?
I'd say there's not only been an increase in demand, but there's been an increase in acceptance of modular construction as a solution for all of the things we're talking about. And for what it's worth, I sat on the international panel of experts in Singapore when they were starting their modular effort. So yeah, I've been in it a long time, and it is an appropriate solution, but it requires a systematic approach that's different from where we were. So that takes a little time, and it's now being both adopted and adapted to fit the needs of the built environment.
Mm-hmm. Great. Well, thank you very much, Roger.
Thank you.
And well, if anyone is interested, they can find your contacts. They can find you on LinkedIn, I guess. And yeah, we'll move on to the next company. Yeah, if you want to just share your, yeah. And now we're going to move on to the next company, which is Carbon Upcycling Technologies. So I'd like to invite Apoorv, CEO of Carbon Upcycling Technologies. Great. Hi, how are you?
Hi, Melvin. Doing well. How are you?
Good, thank you. So I'm making you a presenter. You should be able to share your slides now.
Excellent. Let me know if you can see it.
Yeah, perfect.
Excellent. So thank you, everyone, for the great discussion early on, and for some of the presentations that I've been able to see. I serve as the CEO of Carbon Upcycling. We're a 5.5-year-old company based in Calgary, Alberta. So we are a Canadian company. And we started with the vision of changing the waste of today into the building materials of tomorrow. And I'll talk a little bit about the context as to where we see our technology really fitting in the grander scheme of evolution that we've seen since the industrial age. As many of you know, since the early 1700s, we've been burning a range of fossil fuels, ranging from coal to natural gas to even things like whale oil, to really drive a lot of the progress that we've seen around the world. And there's no doubt that the average human being today is better off than the average person back in the 1700s. And especially in the case of pandemics, we can talk about just the medical advances we've had as humanity across the world. The unexpected drawback of all this progress has been creating a much more stable molecule, such as CO2, that is building up in the atmosphere. And over the last 40 to 50 years, there's been an increasing recognition that this is a problem that not only needs to be solved to make sure that we have a sustainable path forward for the next century, but also that there is a lot of opportunity that comes with solving that problem in further democratizing access to opportunity across the world. A lot of the initial work that has been done in this has been to look at things like biofuels or chemicals that are derived through a circular economy process. And from an energy perspective, what we see as the challenge there is you're now going from a very stable molecule like CO2 and combining it with something like hydrogen to make these fuels. And so you're really trying to reverse or undo all of the energy that we've harnessed from these fossil fuels for the last 250 years, and trying to do that in less than a fifth of the time. And the only way that we see that being sustainable is with the green energy transition that is obviously in place. The cheat code that we think is pretty exciting at this moment in time is something that uses chemical absorption techniques like mineralization, such that you don't have to break this energy void molecule such as carbon dioxide, but you can actually bond it to other materials so that it has a functional purpose. And that's really where the premise of carbon upcycling began. What our technology is able to do is take carbon emissions such as CO2 molecules and chemically activate industrial byproducts or naturally available materials such as serpentine or talc, and activate them so that they can serve as a sponge for the CO2. Once that material has been embedded into the chemical structure of the solid, we found that we're able to tune the production of a range of different nanomaterials such that we have applications of the end products in markets ranging from coating to construction, such as concrete, as well as in batteries. What I'm interested in talking about today is the construction market. Most of the world since the early 2000 BCs has actually been using some form of cement in one way or another, cement being, of course, the binder for whatever construction we undertake. And Portland cement, as it was developed back in the 1820s, is really a glue that makes up less than 10% of the mass of a cubic yard or cubic meter of concrete, but makes up over 90% in many cases, the emissions associated with that volume. What we have shown by testing with a range of different companies around the world, including a couple in France, such as Lafarge-Holcim, is that we're able to take some of the supplementary cementitious materials, such as byproducts of coal combustion or steel slag from steel smelting, and activate them such that the strength that they're able to elicit in a concrete mix is significantly improved. So the real important numbers here are the table, the green highlighted values in the table, which show that we can get up to 40 to 50% stronger concrete simply by treating just a portion of the additive that is used to replace the cement. From an environmental perspective, this has massive implications. It allows us to reduce the amount of cement in a cubic yard or meter of concrete by almost double. And from a perspective of a project, we're currently building a unit here in Alberta, Canada, which would have the ability to reduce carbon emissions per year by almost 1,100 cars a year. And we think that over a global scale, this number can actually grow quite significantly if this technology was to get global adoption. We also see that there is another tailwind that we can take advantage of, which is people looking at alternatives to Portland cement in their mixes. There's been a lot of work both by ASTM as well as the European regulators around looking at validating the use of natural pozzolanic materials such that Portland cement can be displaced at least marginally and incrementally over the next 10 to 15 years. And although cement companies have made a significant progress in changing their fuel sources and becoming more efficient with energy efficiency in their plants, we think that the adoption of SCMs at a global scale is what's ultimately going to drive the change forward if we're going to meet some of the ambitious goals that were mentioned earlier by Vinci and others. In terms of traction, we're very proud of the type of usership that we've been able to build. We do have another product in the construction space, the alpha carbon coating, which is used to prolong the life of infrastructure that sees wastewater corrosion or sewage related corrosion. We've actually had over 600 installations across the US now, mostly in Florida, with a few different household names. And we've also been working with partners, both corporate as well as academic, to advance the type of technology that we're presenting here today. We've been fortunate as well to have won a few awards, and probably most prominently at this point, we're one of the 10 companies in the Carbon X Prize competition, which is currently ongoing and should end at the end of this year. One very exciting development for us was to actually take this technology out to the field just as of 9 days ago. So we actually did a commercial pilot where the technology was installed in a foundation, and we've been able to validate that some of those numbers that I showed earlier with strength improvements and the case for reducing cement actually do hold true at field scale volumes. And as we look towards the rest of 2020, we're looking to take on these kind of pilots both here in Alberta and Western Canada, but also in New York, where we've been fortunate to receive some support from NYSERDA, a local state research and development enabling association. So we're very excited to have been a part of the consortium of startups that are being presented here, and we'd be very interested to talk to anyone who might be interested to learn more and potentially pilot our technology within their own geographical domain. So thank you so much again, and I look forward to any questions the audience may have.
Thanks a lot. Yeah, so let's start. We have the first question. Let me pull it. So someone is asking, what are your next steps in terms of development? So there are a lot of corporates in the list of clients and partners that you have. Do you have any plans on going to Asian or European markets?
Very much so, yeah. So it was interesting. Vinci has actually got an announcement coming up recently about some of the plans that we may have within the European context. But specifically, I think our target is to look at areas where sustainable development is a major strategic goal, either from a national perspective or from a corporate standpoint. With a lot of the political changes that happened in the States since 2016, that hasn't been the major driver for changes there. And I think what we found is that the fact that we're able to make an economic argument where these supplementary cementitious materials like the ones we're treating are already cheaper than cement. So you're not only reducing carbon footprint, but you're also able to make an economic case of being at least the same price as the incumbent, if not cheaper. And so I think the modality, I guess, of being able to offer both those value propositions allows us to kind of look at where the opportunities may lie maybe more expansively than if our argument was just environmentally based. We do have a partnership in Asia right now with a company called IHI, which is a Japanese conglomerate, and we're looking at potential use of this technology or deployment at scale within the Southeast Asian market, like Indonesia and the like. And within Europe, we're talking to a couple of different agencies. We've been in touch with Lafarge since probably about 2 years ago when we were part of their inaugural Lafarge Wholesome Accelerator program just outside of Lyon. And we're hoping that as we work with their Western Canadian branch, we can then build a broader value proposition that they can take to Europe as well. So very much interested. I think the key is to identify the right partners and opportunity. And so if someone is interested to look at that more, we'd be more than happy to have that discussion.
Awesome. Thank you very much, Apoorv. We're going to have to move on to the next company. Thank you so much for your presentation. So next up, we have Chris Stern, CEO of Carbicrete. So,
hi there. How's it going?
Good.
Very good. Can you see my screen?
Yeah, we can see it. Perfect.
Perfect. How's that look? Good? All right.
Yeah, good.
So thanks very much to all for listening and coming to this webinar. So Carbicrete is basically cement-free carbon negative concrete. Sorry, I'm just gonna go down here. So one of the issues with cement is basically that, first of all, it's the most consumed substance on Earth outside of water. For every man, woman, and child that's on the planet today, there's 2 tons of concrete made every year. So it's quite a widely used substance. The issue with that is that the main ingredient that actually holds concrete together is cement, and it's accounting for about 8% of global greenhouse gas emissions, much to Melvin's introduction. That's 2 gigatons of CO2. And then the third problem is evidently, cement uses a lot of raw materials and is very expensive to make due to the amount of energy that is required. So what do we do? So Carbicrete doesn't use cement. We avoid the emissions that are associated with that cement production. And in place of not using cement, we use something called steel slag. Now, steel slag, there's about 210 million tons of this made every year as a direct byproduct of the steelmaking process. There's not a lot of applications for steel slag. Typically, the biggest application is it's used in road beds. So underneath concrete or asphalt, there's steel slag. That's the bigger chunks. All the smaller chunks or smaller bits get put into a landfill. It's not toxic or dangerous to life, but it is. It's just one more thing that steel companies have to contend with. So we don't use cement. We use an industrial waste byproduct. And number 3, we actually cure the concrete with carbon dioxide. So that's the three things that Carbicrete does. It solves a problem for steel manufacturers because it's getting rid of that thing that they have to take care of, and it reduces landfill waste. We also reduce the GHG emissions, and by curing the concrete with CO2, we permanently sequester it inside the concrete and permanently remove it from the atmosphere, such that even if you break the concrete in 100 years, the CO2 is not released. So it's a permanent solution for emissions. So the value proposition with our concrete, typically concrete takes 28 days to gain full strength. With our concrete, it has full strength within several hours. It's also carbon negative, and that's not just us saying that. There's a third-party engineering firm that looked entirely at our process chain and determined that we're carbon negative. I'll give you an example. For a concrete block, or otherwise known as a concrete masonry unit, we are avoiding 2 kilograms of cement, and therefore we're avoiding 2 kilograms of CO2 because it's about 1 for 1. 1 kilogram of cement emits 1 kilogram of CO2 during manufacturing. So avoiding those 2 kilograms. And furthermore, between half a kilogram and a kilogram of CO2 is permanently sequestered during the conversion process. I say between half and the full kilogram because it depends on the mix ratios and how much you want to focus on cost versus carbon uptake. Another thing that we've determined over the last 8 years is that our concrete's up to 30% stronger in compressive strength. So it's a better product. It's also a little less expensive to make because we're using an industrial waste byproduct. It's also a product of us targeting the market at a specific cost to the concrete maker. Because Carbocrete is, we're not actually making concrete, we license the technology and we bring the supply chain. And on that note, we have a lot of investments, you know, from various levels of government in Canada, but our first private investor is Harsco, which is a Fortune 500 steel mill services company, the largest in the world, that is operating on 140 different plant sites all over the world, because the key ingredient is steel slag. And, you know, we have all kinds of IP protecting our concrete, but you cannot make the product without the precursor material slag. So we've got a worldwide supply and marketing agreement together with Harsco in order to serve our customers. So I open it up to any questions.
Sorry, thank you, Chris. Yeah, so we have a question. So since you're based in Montreal, Canada, someone was asking if you got any incentive to develop your product, like from public organization or from anyone, since you know you're developing a sustainable clean tech solution.
Yeah, so it's been publicly announced. I mean, we have a lot of support, but the public announcement is from a arm's length government association called Sustainable Development and Technology Canada, which is a subset of Industry Canada, and we got a $2.1 million grant from them.
Awesome. And so compared to what can be done in the US, like in terms of incentives, like how does Canada work in that way? Like, are they really supportive to companies like you, or do you think in the US there are more opportunities to get incentives? Like, how does this work?
So in the past, I mean, the US has done things in the past, like from the DOE in different industries called loan guarantees. There's not a lot of grants, I don't believe, in the US for things like this. It's possible there are some, but I believe in terms of starting a technology like this, Canada is a much better place.
Yeah, that's interesting, since you know we were talking about regulation and incentives, stuff like this. Well, we have another question. Someone is asking, how do you source the CO2 that you're curing, and how much does it cost? Yeah,
it's a good question. I mean, the CO2 is basically there's no real market for carbon dioxide right now outside of you know, beverage as well as enhanced oil recovery. So that's why all of us on this phone call, on this this webinar, are focused on how do we create markets for carbon dioxide. And so currently we have to buy beer gas, which is, you know, between $100 and $200 per ton. It still makes economic sense with our technology, but the end game is to use flue gas from cement factories or steel factories or places like this.
Great. Well, thank you very much, Chris.
Thank you very much.
Contact right here. So I saw that LinkedIn invitation pop up. I hope it's someone from the webinar today. And yeah, we'll be in touch.
Thank you.
Thank you. And so last but not least, we have Mitch Lewandowski, Chief Commercial Officer from Branch Technology with us. Hi, Mitch, how are you?
Good, thank you. Can you hear me okay?
Yeah, perfect. And we can see your slide full screen. That's perfect.
Great, super. Let me just move you out of the way now so I can actually see my slide as well.
Perfect.
Super. Well, good afternoon and good morning, everyone. My name is Mitch Lewandowski, and I'm the Chief Commercial Officer at Branch Technology. We're based in Chattanooga, Tennessee. And just to be brief today, we're just going to be talking about how we're empowering responsible innovation through large format 3D printing. I know there's been a lot of buzz in the marketplace these days about 3D printing and the ability to bring it into the construction environment. We've done something rather unique. We developed a process called CFAB, or cellular fabrication. We brought this into three particular market verticals. We've got some strategic partnerships. We're doing direct deals to customers, and then we've got a lot of government work that we're doing these days. The cellular fabrication is where we actually do this large format printing, and we're using 1/20th of the material to print in open space. Some of you have seen the videos online that talk about this. And what it does is just allows us to make very large items that are lightweight and use minimal material. So when you think about large, we could actually print something larger than we could ship. So we always say, people say, how big can you make it? I was like, I can print something to fill up a lot of space, but we just can't get it out of the building. So that's one of the limitations. We were talking earlier on modular fabrication, the logistics of getting it to the job site. That usually is the limiting factor. So very large products, completely produced in-house, and this creates a lot of impact because you can brand a building. We'll actually be showing you some examples just in a moment of what you can do on the outside of a building. So that's where we're spending a lot of time right now. So in this autonomous manufacturing environment, we're actually doing direct digital design, and then we're pulling that design from the constructed model of the building. We're bringing that in right into fabrication. We can actually produce a lot of very complex items because of that in our 40,000 square foot facility, and then we push that out to production. So just to give you an idea what that would look like in a production cycle, starting with a model, the 3D model, we run it through our tech stack. It goes out to robotic production. Using this example would be for exterior building envelope panels that would go out to the job site and get hung on the building and installed complete. There's no material waste. You're not cutting anything on site. Everything's coming pre-made and ready to go on the outside of the building. So here's some examples, some projects we're involved in. We just had, the bottom left-hand corner, that's a parking garage we're involved in. And while we were sitting in the meeting, the builder was double checking on the bond. Say, hey, did you get the bond yet? We had a meeting on it yesterday. It was yesterday afternoon. You gave me like 6 hours. The bond's not there yet. But one of the things these days, especially in the current environment that we're in of COVID, is the desire to make a building or a project iconic, different, and or unique is very important. It was important before, but it's really gotten developers and builders much more interested in that space. So like what you can see on the right side of the screen, that was a flat building where we took it and we did something unique to make it stand out. And that's just some of the kinds of design freedom that we can create on the outside of a building using our 3D printed capabilities. It's called BranchClad. There's another big market globally for theme-based environments where you want to do some kind of natural rock work, some natural stone work, recreate, something that looks like a mountain. Think about a theme park and so forth. So in this particular product that in this particular product, which is called Stratiform, we can 3D print and mill these out in the factory and send them in very large chunks to the job site and be assembled right quickly and do a massive wall assembly in a short amount of time, which is very efficient on the job site. Typically right now, if you're doing something like this, you're bending a bunch of metal, you're putting a mesh over it, you're spraying shotcrete in, and then a bunch of artisans come in and they handcraft this. So it's very wasteful from a time and energy standpoint. And then one other product category that we're in, we call it C-Form. This is where we are able to, again, use this large format 3D printing to do freeform structures and to be able to create something really unique. The one in your upper right-hand corner is a hanging plant assembly, and that's made out of a biomaterial that we worked in. That's in the Field Museum of Natural History in Chicago to celebrate their 150th anniversary. And that particular product, that's 38 feet across, and it's hanging way up in the air. The product on the left side is a project we did for Art Basel Miami. And we did 2 of those, and at the time, those were the largest 3D printed freeform structures in the world. We've since done much larger projects than that, but that's a pretty interesting one that's gotten a lot of buzz. And then at the bottom, that's a project that we did called Curve Appeal that got over 1 billion social media views online. So lots of great partners working with us, from customers to collaborators to companies that have been involved with us. We've got over 100 man-years in software development in our process and in technology development. So even though we may have started in a garage, as they say, we're not in a garage anymore, and we spent a lot of time to get here. So everything's been patented from the front to back end, and we've got about almost 250 unique IP items in this process. And if you've got any questions, we'd love to hear from them. Again, my name is Mitch Lewandowski with Branch Technology.
Thank you very much, Mitch. So yeah, feel free to use the question box to ask your questions to Mitch. Well, someone wanted to know more about the type of materials that you're working with.
Yeah, that's a good question. So we work with a variety of different materials depending on the project type, but some of what we work in is a carbon fiber in a reinforced polymer mix or biopolymer mix, depending on, again, what the project is. So the material is important. What's more important is the fact that we use such a little material in the manufacturing process, and that the robots are very low energy. So when we're making something, we can make something large and strong with using minimal materials and minimal energy to get it done.
Mm-hmm. And you were also mentioning the foam that you put inside the structures. Can you tell us more about the type of foam you're using?
Sure. When a project needs, we start out with the matrix, which we use that a lot on projects, and the matrix itself is actually shown invisible. And then in a second step, we will print something, we will infill it with a fire-rated foam, and then another robot will topographically mill that surface, and then that may go out to the project. And then lastly, we could print foam and mill, and then put a surface finish on it, whether it's a GFRC or some kind of decorative material, like for example from Stowe or somebody, where that would go on the outside. So the foam would be a fire-rated foam, and the foam working in conjunction with the matrix actually creates a stronger material. We were talking just a little bit ago about CMU size blocks. If you had a CMU size block of the matrix that's been foamed and milled, it will support 6,000 to 10,000 pounds in compression, depending on the orientation of the cells of the matrix. So you can think the ability to do some very strong, very lightweight structures. That CMU block weighs about 2.5 pounds.
Mm-hmm. Well, thank you very much. On that note, I'm just gonna wrap up. Let me get back the screen. Great. Well, thank you, everyone. So that was Sustainable Construction. We organize about 30 events like this one, usually in person. Well, now it's online. So we organize, 30 events like this. The next one is going to be about mobility. It's going to be on August 26th. So we'll talk about electricity, electrical vehicles. We're going to talk about infrastructure, autonomous vehicles, etc. So feel free to reach out, to follow us on LinkedIn, etc., to keep up and keep in the loop about everything we're doing. And here are my contact information if you want to reach out about some of the things we've been talking about today. Thank you.